Okay, so today we are going to continue adding and subtracting rational expressions, and then we're also going to multiply, no dividing it, just multiply. Okay, so for page 22 in your packet, there are 5 adding and subtracting problems. I'm going to do numbers 1 and number 5. You can do 2, 3, and 4 to use to study for the unit test that is coming up soon. So for number 1, I have to factor the denominator to see what my common denominator is going to be. I'm going to leave the numerator alone. So what multiplies to negative 21 that adds to negative 4 is negative 7 and positive 3. So what's nice is this binomial is already in both expressions, so the least common denominator is the factored denominator here. So this problem is missing the x plus 3. And I have to be careful with the subtraction. So I'm going to keep, it's not a solving problem, so I'm going to keep my denominator. And then my numerator is going to become x plus 2 times x plus 3 minus the entire trinomial from this expression. So the negative has to be distributed. And I have to multiply these two binomials together. So x times x, x times 3, 2 times x, 2 times 3, and then distribute the negative. So now in the numerator I have to combine like terms. So x squared minus x squared is 0. 3 plus 2 minus 4 is 1x. And 6 minus 13 is negative 7. And what I see is this factor and this factor are the same. So they eliminate each other. Anything divided by itself is 1. But you can't leave the numerator empty. It divides to 1s. So our final answer is 1 divided by x plus 3. Okay, so then for number 5, we have 3 expressions to combine. I'm going to factor the denominator on the right. So what multiplies to negative 3 that adds to 2 is going to be positive 3 and negative 1. So this is my common denominator, which is nice because each of these has one part of that expression. So this is missing the x minus 1. This one is missing the x plus 3. Since we're not solving, you can't ignore the denominator. So, sorry, I need some space. Our denominator is going to be x plus 3 times x minus 1. And then this is going to be 2 times x minus 1 minus x times x plus 3 plus x squared plus 2. So to simplify, we're going to distribute the 2 and distribute the negative x. And then negative x squared plus x squared is 0. Let me rewrite my denominator. So then 2x, there's no common term. Negative 2 plus 2 is 0, and then I have the minus 3. So nothing in the this entire binomial in the numerator does not match a denominator expression, so this is our final simplified answer for number 5. Okay, and now to page 23. What we need to look for when it's multiplying, it's really like the entire numerator divided by the entire denominator. Because when you multiply fractions, you multiply numerators, multiply denominators. So we're looking for any factor divided by itself to divide to a value of 1. So for number 6, everything's already factored, which is great. So I'm going to combine my numerator, rewrite my denominator, and look for any matching factors. So n minus 3 divided by itself is 1. Let me get another color. N plus 4 divided by itself is 1. And then nothing else matches. So our numerator, we're left with 7n squared times 1 times 1. So that's just 7n squared. And then these two binomials left in the denominator. Okay, so let's try 7. To save a step, I'm not going to rewrite the whole equation with one big fraction bar. I'm just going to imagine it's connected with multiplication. So what I can see is p minus 4 divided by p minus 4 is 1. Nothing else can divide, so we're left with p plus 6 times 1 divided by p minus 4 times p minus 2. Now in 8, I have to do some factoring first before we can divide. So let's see, 7n, nothing can factor. 9 and 24, they can both divide by 3. So I'm going to factor out a 3. 24 and 64, well, let's see. Oh, they can both divide by 8. And then they also share an n squared. So I'm going to factor out 8n squared. I'm left with 3n minus 8, and then the 7n. I could multiply here and make this 21, but I'm not going to yet because 7n divided by 7n is 1. 3n minus 8 divided by 3n minus 8 is 1. Let me see what I'm left with. 3 divided by 8n squared. Can the 3 and 8 reduce? No, so that's our final expression. For number 9, I'm going to combine my numerators, and now what multiplies to negative 27, that adds to 6. 3 and 9, with the positive 9, negative 3. So these eliminate to 1. So our final answer is p minus 3 over p minus 9. And last but not least for 10, 3b squared and 18b have a greatest common factor of 3b. I'm going to rewrite my denominators multiplied. b plus 6 divided by itself for a final answer of 3b over b plus 8. You cannot divide these b's because b plus 8 is the whole term, and you cannot separate this b from the plus 8 to divide those. So this has to be the final answer. Your homework is all of page 24. Don't forget to check your answers.